Hi everyone, welcome back to the second part of our series on sequences and series. Today we'll be covering the second part of this crash course, which will be on the summation. Alright, so what is the summation? The summation is just a fancy kind of way of writing a long sum. So let's say we have a lot of terms to add up. We don't want to write u1 plus u2 plus dot 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 dot. We can summarize this entire thing in this one notation over here. So as you can see, we are summing ur starting from r equals to 1 all the way to n. So this n here actually means r equals to n. So it means we are adding up all the ur plus dot 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 plus ur. But for every single r, we are replacing it with the values from 1 to n. So it becomes u1 plus u2 plus u3 plus all the way to un. Okay, so for example, this thing over here will be equals to, okay, so if we copy this out n number of times, because basically we are summing this term many times. Okay, so we write out a whole bunch of these same term, and we are summing from r equals to 1 all the way to n. So what do? We take each r term and we substitute it with their corresponding r value. So for the first term, we start with r equals to 1. So with 1 squared plus e to the power of 1 over 3 times 1 plus 1. Basically, we're replacing all the r's with 1. And for the second term, we go one step up and we replace everything with 2. Okay, so we continue doing this by replacing the r's with 1, 2, 3, so on, all the way until n. So the last one would be n squared plus e to the power of n over 3n plus 1. So this is what the summation actually means. Okay, so I'm going to go through some properties of the summation with you. Don't worry if this is a little bit confusing or the notation looks a bit complicated at first. So if we multiply an entire summation by, say, some constant c, if we were to expand this summation out, we are basically adding ur from a all the way to b. So it will be ua plus 1 plus ua plus 2 all the way until we hit b. Right? And using the distributive law, we can expand this bracket out to become this. And we can actually rewrite this as the summation of cur, where r ranges from a to b. So you can see that in the summation, we can actually bring in this constant to become summation of cur. Okay, so what happens if we add two summations together? Okay, when we add two summations together, say they have the same starting point and the same ending point. So for summation of ur, it would be ua plus all the way to ub. And let's say we add another sequence v. So vr from a all the way to b, va plus all the way to va plus 1 all the way to vb. So we can actually group these together, the ones with the same index, to get ua plus va, ua plus 1 plus va plus 1, all the way until the last term, ub plus vb. So you realize we can actually write this as another summation of this bracket, ur plus minus vr, because this can be minus also. Okay, so ur plus vr, we can actually write it as a summation of this from r equals a to b. So if our starting and end point is the same, we can combine the two summations. So if we're summing this sequence and we're summing this sequence, we can actually add them together and sum over the whole thing. Okay, so there's another kind of property which is very special. What if you are summing a constant? C here is a constant. So there's nowhere for your r to substitute into this expression over here, right? So imagine we were to do something like c plus many times c. Okay, and then just now with our example over here, for each one we would sub in the relevant r value, right, from 1 to all the way to n. But for this one, we can't really do that because there's no r in the expression, so we just leave it as it is. So all we're still left to do is to think about how many terms there are. So the first term would be for r equals to a, this one is r equals to a plus 1, all the way to r equals to b. So there's actually b minus a plus 1 terms. For example, why the plus 1? So say I give you a sequence of numbers 3, 4, 5, 6, 7. 7 minus 3 is 4, right? But there are actually 5 terms here, so we have to add 1. Okay, so we just take b minus a plus 1, this is the number of copies of C we have, and since C is a constant, we just multiply it by C. Right, moving on. There's this thing called shifting the index. So the index means these things. These are the indices. Okay, so what does it mean by shifting the index? We can also rewrite u1 plus u2 all the way to un as u2 minus 1. The 2 becomes 3 minus 1, 4 minus 1, and so on, right? So we realize we can actually rewrite this in a form something like maybe ur minus 1, and then our summation will be different. So this will be equals to the summation of ur minus 1, but instead of starting at r equals 1 here, right, we are now starting at r equals to 2. So the first term would be u2 minus 1. The second term, r will go one step higher, become 3, right? So 3 minus 1, all the way until we hit n plus 1 minus 1. So this is a possible way to shift the index. From 1 to n now, our starting point is 2, and our end point is n plus 1. But we have to change this index from r to r minus 1. Okay? Okay, sorry, this one here is actually r is a typo. So the r becomes r minus 1 when we shift up the index. Okay, so pause the video for a while and try to fill in the blanks as shown on the screen. Alright, so we're going to be presenting the solution for this question to you now. So here we have the index from 1 all the way to n. Now we want to shift it to begin at r equals 0. So what happens when r equals 0? The same r here, 1 squared, right? If we were to start with 0, it has to be r plus 1 squared, right? Because here we have 1 squared as the first term, then 2 squared, 3 squared. Now we're starting from 0. So in order to get the same term, we have to add 1 to our r. Okay, and instead of reaching n, we will only be reaching n minus 1 because we are covering the same n terms. Right? And the last term, which will be n squared, is now n minus 1 plus 1 squared, which is n squared. So all we have to do is substitute all the r's with r plus 1. And this is our answer, and of course we can simplify the bottom, but that's not too important for now. And as for r equals to 3, now we are substituting all the r's with r minus 2. For example, the first term, we want to get 1 squared, right? So we will take 3, subtract 2, and get 1 squared. And we'll end at n plus 2, so it would be r minus 2 squared plus e to the power of r minus 2 over 3 times r minus 2 plus 1. And of course, we can simplify the bottom as well. Right, so we're going to be going through some techniques in solving summations, okay? So the first and most important technique in solving summations is to break the question apart. Because some questions, the terms in the summation, right, they can be split into several summations. And these smaller summations are usually easier to compute. And then after we compute each of them, then we can add all of them together. Okay, so here's an example. If we were to consider the summation of this strange looking expression over here, so what can we actually do? We can actually separate these two into separate summations, right? So we can write it equals to like this, and 2 times 3i plus 5 would be 6i plus 10, plus the summation of 6 to the power of I. And now again, we can split this into 6i and 10. So it becomes a summation of 6i, which is 6 times the summation of I, plus the summation of 10 from 1 all the way to n, plus the summation of 6 to the power of I. Alright, so let me just copy what I wrote here. Right, we have this. And last but not least, 6 to the power of I. Right, so let's start by calculating the first few first. Okay, the first summation we have over here, this is just a summation from 1 all the way to n. Can you see? Because we are replacing I with 1, then I with 2, then I with 3, all the way to I equals to n. So this is just 6 times 1 plus 2 plus all the way to n. Okay, now let's look at the next summation. Do you realize this is actually a constant? So we're actually adding the same constant many times, and we are actually adding it n times because we're going from 1 all the way to n. So this is just 10 times n. And as for the last one over here, we are adding up 6 to the power of I from 1 all the way to n. And so doesn't this look like your geometric progression? So we have 6 plus 6 squared plus 6 cubed plus all the way to 6 to the power of n. Alright, so for this thing over here, it is easy to compute because we actually have a formula for this, which is 6 times n plus 1 over 2, okay, which is 3n times n plus 1. This is the formula for the summation of the first n numbers. Right, then we plus out 10n. Okay, and then how are we going to add this thing together over here? Okay, so if you recall the formula from our previous lesson, then that will be really good. If not, I can go through with you on how to find this sum. So let's say we let y be equals to 6 plus all the way to 6 to the power of n, right? If we multiply the whole thing by 6, we get 6 squared plus all the way to 6n plus 6 to the power of n plus 1, because n will become n plus 1, right? And what happens if we take this expression 6y and subtract y from it? We will get 5y equals to 6 to the power of n plus 1 minus 6. So in order to find our original y, we just have to take this and divide it by 5. As follows. And that's our answer, so we can simplify this. Okay? So this is a rough overview of how to split up terms in a summation, because it is much easier as compared to trying to evaluate this entire thing as one whole, right? Right, so the second technique in solving summations is adapting to a given formula. Okay? So the most common formulas that are provided would be the sum of the first n numbers, as I showed you just now, 1 plus 2 plus 3 plus all the way to n, being equals to n times n plus 1 over 2. And there's also a standard formula for the sum of squares. So this would be 1 squared plus 2 squared plus 3 squared plus all the way to n squared. And this is a similar sum for cubes. Okay? So other than this, so sometimes the questions will give you a formula and they ask you to use this formula to solve the summation. You don't have to memorize these two formulas because they cannot be quoted. You can only quote this formula over here, okay? So other than the first formula here, you cannot directly use these other two formulas unless they are provided in the question, and they'll probably ask you to use it to solve the summation. Okay, so for example, let's say you're given these two summations. So remember, if they don't give you, you cannot quote these summations. Okay, so we want to find this very strange looking summation over here. So how are we going to go about doing it? Okay, so what we can do is we can first expand out this thing here. Right, so we get, let's say we were to work with the first two brackets first, we will get r squared plus 2r minus 3 times r plus 5 equals to the summation from 1010 to 2020 r cubed plus 5r squared plus 2r squared plus 10r minus 3r minus 15. And this thing over here is equals to r cubed plus 7r squared plus 7r minus 15. So we can actually split this summation into 4 parts because we have the general formula for the summation of a cube. So we can split it up. We also have the general formula for r squared. So we can split it up as well. And we can quote the sum of the first n numbers, like the summation of r, which is this one is given here, this one over here. Right, so we can actually use this. And for the last one, we're just multiplying a constant many times. So we can split it into 1010 to 2020 r cubed plus 7 1010 2020 r squared plus 7 1010 2020 r minus 15. Okay, so let's approach each of these individually, okay? So how do we work with this term over here? Okay, so this term asks us to add all the cubes from 1010 all the way to 2020. But this formula over here gives us the formula for the sum of the cubes all the way from 1. So 1 cube plus 2 cube plus all the way. But here we are kind of starting halfway. So what's our solution for that? So we can actually use this. We just add up all the cubes first. So start from r equals 1, 2020, r cubed, and then we subtract the first 1009 cubes. So after we subtract the first 1009 cubes from this, we'll get the sum of these cubes. So from 1 all the way to 1009 r cubed. And we do the same thing for this, so it becomes 7 times r equals to 1, 2020 r squared minus summation of r equals to 1, 009 r squared plus 7 times. So you have to be very patient when working through these questions because they can be very tedious. Okay, then the last one here, we are just adding the number 15 many times. So how many times are we adding it? We are adding it 2020 minus 1010 plus 1 number of times. So this is actually our answer, and how do we work this out? We can use the cube formula from 1 all the way to n to find this one and this term over here. So these two terms are settled. As for these two terms, we can use the sum of the first n squares formula to do these two terms. Because these two are all given, so we can find the first 4 terms easily. As for the sum of the first 2020 numbers and the sum of the first 1009 numbers, this formula can be quoted. It is n times n plus 1 over 2. So this would be 2020 times 2021 over 2. This would be 1009 times 1010 over 2. And the last part can be calculated as well. So that is how you find this super huge summation over here. And this will take very long. So it is important to check your work after every single step and make sure you don't write any of the numbers wrongly. Okay? So let's move on to the last technique in solving summations. So this technique is actually called the method of difference. So sometimes when the term in the summation cannot be split, right? In H2 mathematics, it will guide you to apply a method known as the method of difference. So what is the method of difference? Okay, so the method of difference is, let's say we're adding n terms, u1 all the way to un. And let's say we can express each term, right, as a difference between two different things. So let's say our u1 is v1 minus v2, u2 happens to be this same v2, v2 minus v3, v3 minus v4, so on, so on. If we want to add all these terms together, right, it becomes equivalent to adding the right side. And we see the v and the v2, the v2 and the v2 cancel out, v3 and the minus v3 cancel out, so on and so forth. Everything cancels out, even a vn minus vn cancels out too. So we are only left with the first term and the last term. So let me show you a demo. So let's consider this question. Okay, we want to add ln r plus 1 over r minus 1 from 3 all the way to 2020, and there's no obvious way to split this into multiple summations. Okay, so what we actually do, right, is we realize that ln r plus 1 over r minus 1 is equals to ln of r plus 1 minus the ln of r minus 1. So this is what we're going to be summing. Okay, so let's start with r equals to 3. We get ln 4 minus ln 3 minus 1, which is 2, right? And then we move on to r equals to 4. It comes to ln 5 minus ln 3. So far there's nothing much we can cancel out yet, right? Then we move on to r equals to 5. Then it becomes ln 6 minus ln 4. So write out as many as you can to make it clear to you. Plus ln 8 minus ln 5 plus all the way until you reach, sorry, let me move this away, till you reach ln 2020 minus ln 2018 plus ln 2020, so 2021 minus ln 2019. So now we actually make the realization that we can start cancelling out 2 rows apart. The ln 4 will have a minus ln 4, ln 5 will have a minus ln 5. sorry, this is 6, ln 6 with a minus ln 6 too. So everything ends up cancelling out. Okay, so draw all these lines showing they cancel. Alright, until we are left with these four terms, ln 2020, ln 2021, ln 2, and ln 3. So our answer will simply be equals to ln 2020 plus ln 2021 minus ln 2 minus ln 3, which is equals to ln 2020 times 2021 divided by 2 times 3. Okay, so this is a way you can use method of difference to find the summation of something that looks pretty odd. But remember, you always have to draw these lines to show the cancellation in your working. Okay, so sometimes the difference may not be so straightforward, like you see this, you just cancel between every 2 rows. You don't have to like skip a row and cancel. But here we had to do that, right? The ln 4, the next ln 4 is only found like 2 rows away. So if you don't write it out enough times, you may not find this ln 4 over here. You may not be able to see the pattern. So as long as things cancel out, you are happy. So when in doubt, just write it out. Just write out many copies of the difference until you start to see a pattern, and you'll be able to see the cancellations more clearly as well. So the moral of the story is just don't be scared of summation questions. Okay, so in every question pertaining to the H2 level, it will be very clear when you need to use APGP and when you need to use method of difference. Okay, so when the need arises to use the method of difference, most questions will guide you to discover the terms that cancel out. So very frequently they like to use partial fractions. So partial fractions can be something like, find this summation. I'm just going to write it out like this, okay, plus so on. This can be written as a summation. That's maybe 9 times 10. Okay, if we do partial fractions on each of these fractions, 1 over 2 times 3 is actually half minus 1/3. 1 over 3 times 4 is actually 1 over 3 minus 1 over 4. 1 over 4 times 1 over 4 times 5 is actually 1 over 4 minus 1 over 5. So do you see there's also a cancellation going on here? So most questions will guide you to do partial fractions or something similar, okay? So I've come to the end of the summation crash course, and this is also the end of our 2-part crash course to sequences and series. I hope you have understood this topic, and feel free to drop me any questions if you have anything to ask. Okay, thank you so much for tuning in, and see you in our next video.